Hi, I'm Vagrant Gautam, and on behalf of my other co-authors, Julius, Eileen, Ray, Anna, and Dietrich, I'm going to be presenting our paper introducing our dataset WinoPron, where we revisit English Winogender schemas for various aspects, including consistency, coverage, and grammatical case. Our work builds heavily on Rudinger et al.'s Winogender schemas, which is a widely used challenge set to evaluate gender bias in coreference resolution. So let's walk through an example of it for those of you who aren't already familiar. The dataset consists of paired templates, as shown here, where there are two human entities, an occupation and a participant, and a third-person singular pronoun. This particular example is about a cashier and a customer. So the first template is the cashier told the customer that his, her, or their card was declined. And the second template is the cashier told the customer that his, her, or their shift ended soon. You might have noticed that the endings disambiguate the coreferences such that the first template's pronoun has to refer to the customer because only the customer's card could be declined in this context, while the second template's pronoun has to resolve to the cashier because only the cashier's shift could end soon. So similar to Winograd schemas, the templates are meant to be identical up to the pronoun, and then the ending of each template should disambiguate the coreference such that one template in the pair refers to the occupation and the other in the pair refers to the participant. And finally, changing the pronoun, for example, from his to her, should maintain the coreference. And this allows us to measure whether coreference resolution systems might be under or over resolving certain pronouns to certain entities in a way that reflects gender bias in society. Unfortunately, if you look a bit closely at this data set like we did, you'll find some problems. So first off, the structural constraints that I outlined are violated in many template pairs. So the fact that they have to be parallel up to the pronoun is violated. Secondly, the dataset conflates different grammatical cases, treating he, him, and his as equivalent and all standing in for masculine gender bias. And this reflects an assumption that these biases should manifest in the same way in coreference resolution systems, even though there's no evidence that that should be the case. Finally, 17% of the Winogender schemas dataset requires modification to work with singular they. And this is because this pronoun has different verbal agreement from the others. So you can say he was qualified or she was qualified, but you have to say they were qualified. So in addition to these three main classes of errors, there are also typographical errors. And what we do is we introduce WinoPron, which is a new data set where we fix all of these issues. So we fix all issues of consistency, so typos, non-parallel templates, stuff like that. And we also design our templates such that they support all third-person singular pronouns by default. And this allows us to add Z-Zem-Zir to the evaluation as well. So our final set of pronouns that we consider are he, him, his, she, her, her, they, them, their, and Z-Zem-Zir. And this can also be extended to arbitrary neopronouns because of our dataset design. So while creating our templates, we also make sure that we balance the dataset for grammatical case. As this table shows, Winogender schemas consisted mostly of templates with nominative pronouns and only 4 templates with accusative pronouns. But in WinoPron, we balance this and we make sure that there are 120 templates for each grammatical case that we consider. And this allows us to actually evaluate that assumption from earlier about how the same pronoun in different cases might have similar or different performance and biases. Finally, we add single entity versions of the sentences with 2 entities to help establish baselines for coreference resolution performance on a simpler task. So we evaluate our data set on the following models for performance, consistency, and bias. We use 2 supervised coreference resolution systems, LingMess and CorCoref. We use SpanBERT base and large, which is a pre-trained encoder-only language model, which is fine-tuned for coreference resolution. And we also test with prompting FLAN T5, which is a pre-trained encoder-decoder language model, that is not explicitly fine-tuned or trained for coreference resolution, but it is instruction-tuned on the task. I'm only going to show you a subset of our results in this presentation, but you can refer to the paper for more. Our first finding is that accusative pronouns are harder. You can see this by looking at how all of the X's representing accusative pronouns have lower accuracy than the circles and squares, which represent nominative and possessive pronouns. As far as we know, no one has shown this result before, and it's really interesting because it holds across pronoun sets and models. One hypothesis for this is that accusative pronouns are roughly half as common as tokens of nominative and possessive pronouns in pre-training corpora, but we have some more sentence-level hypotheses in the paper. The previous figure showed accuracy, which is a performance metric, according to which all models perform a little bit better than chance, at least. And in addition, we also look at consistency metrics. We also report additional performance metrics in appendices, so F1, precision, and recall. For the consistency metrics, we essentially group related instances together, and then we look at how they perform at the group level. So for pronoun consistency, we group the same template by the he, she, they, and z versions, for example, and then we measure whether a model gets all four of them right. And for measuring disambiguation consistency, we look at the two templates that disambiguate the coreference between, let's say, the cashier and the customer. And we look at whether models can resolve both of them correctly. So with these consistency metrics, it becomes clear that accuracy overestimates model performance, and consistency metrics present a bit more of a realistic picture of how these systems resolve coreferences. So the smaller sizes of FLAN T5, LingMass, and SpanBERT base are not terribly good, and the others are more consistent in their responses. We also introduced a new method for evaluating pronominal bias, which treats pronoun forms as independent from social gender. So in other words, we don't assume that he, his, and him should all map to the exact same social gendered stereotypes. Our method also disentangles performance and bias, and you should refer to the paper for details on the method, which we apply to SpanBERT base and SpanBERT large. And as the figure on the right shows, we find that SpanBERT base shows bias in a higher percentage of templates than SpanBERT large does. So unsurprisingly, our method shows that qualitatively speaking, a given model has disjoint biases between he and she, for example. So SpanBERT base positively associates he with engineer and she with hairdresser and painter. But perhaps more interestingly, we find that with our method, we can see that biases are not qualitatively consistent across different model sizes. So SpanBERT base and SpanBERT large are two sizes of the model that has the same architecture and that is trained on the same data. But SpanBERT base learns a positive association between she and machinist, while SpanBERT large associates she with hairdresser and painter. So this is really interesting to see that those are disjoint. We also find that biases are not qualitatively super consistent across grammatical cases. So there's a very small overlap, for instance, between SpanBERT base's biases with they and biases with their. But we even see some contradictory associations. So for example, SpanBERT has a tendency to over-resolve them to manager, but it has a tendency to under-resolve their to manager in the presence of something else. So to summarize, we introduced WinoPron, where we fix various issues with the Winogender Schemas dataset. When we evaluate models with it, we find that grammatical case matters a lot for performance and bias. And we see that biases are complex and sometimes unintuitive. Our broader takeaways are that people should study grammatical case more. They should be very careful about conflating social gender with terms that index it, which are worth studying in their own right. And finally, thoughtful data work can really dramatically affect conclusions. Please read our paper for more details, and I'd be happy to answer questions at EMNLP or over email. Thanks.